Right, so this is, oh. Ready to start? I'm sure you guys are ready. So this is Ron Sluter's talk about using motors, which I'm going to try to give. Let's see. So there's an overview. Motor record features are, guess what I'm going to focus on. There's quite a long history to this record. It started out, 25 years ago or so, and a whole bunch of people have been. And right now, I would say that Kevin Peterson is sort of the mom for this module, who takes care of everything. Yeah. So, like all of the other Synapse modules, the stuff is in there: user displays, there are databases, the motor record, and there's a whole bunch of device support and drivers for a whole bunch of different motors. And the idea is that you shouldn't have to worry about what kind of motor you're talking to. The motor record just, whether it's a stepper or a servo or a piezo or whatever, the motor record just makes it all look like the same thing. And this module also contains examples. A lot of Synapse modules contain example IOCs that are intended to, not to run, but just to show you how to load databases and talk about start drivers and things. So that's your that's the motor display that most people use most of the time. And at the APS, people will have like 30 of these things up on various displays, various workspaces. And the idea is that you can put them wherever you want and organize this. So with CSS Boy, it's a little bit different because the idea behind CSS Boy is different from the idea behind MEDM. And that's unfortunate. We don't know enough about how that works in order to design displays that are really ideal for CSS Boy, and you guys do. So you should feel free to modify the OPI files that are in the motor module so that they do something that you want. Because what we do is automatically translate all of our display files from MEDM to CSS Boy and CAQTDM and EDM using translators that are not trying to, they're just trying to get an OPI file, right? And it might not be what you want. So what we have in most of the modules, and I think the motor module now has this, is an auto-convert subdirectory of OPI with those, and then with those displays that have been auto-converted. And then when you guys find out that that's not what you want, then you can, I don't know how it works in CSS Boy, but you can fix that display and put that in the OPI directory, and that will override. So this thing has a couple of features. There's a tweak value and then tweak forward and backwards, and that's what the users spend a lot of their time doing if they're messing with motors. They typically don't be typing in stuff. There's one other thing. You can set and use this. Maybe there's another display that, yeah. So the motor record has user and dial and raw values. And the idea is that you can, the user is able to put this thing into set mode and then just type whatever value you want, and that's what the motor is going to be. That's the current location of the motor. Even if the dial value and raw values are different, the difference will be absorbed into this offset, and then you can go back into use, and then you can just pretend that it's basically just a coordinate offset. And you can also change the direction. So that's the limit of the difference between user and dial. It has to be linear, and it has to involve an offset and a sign. Oops, wrong way. So those are all the manufacturers. I'm sure this is captivating information for you. You guys all use Delta Tau for everything?
We have some smart act.
I'm sorry?
We have some smart act.
You have Smart Act?
Yeah.
So I guess it's inevitable that there's going to be different types of motors here, and if they're in this list, then you can just use them as motors. So if you want to know if a controller has EPIC support already written for it, I mean, you can look at this motor record document that it's now on GitHub. All of this, I don't have a source for this, all right? All of these things, you might still be able to find them here, but everything is on GitHub in the place that I showed you yesterday, github.com or something /epics-modules. That's where the motor module and all the other Synapse modules are. You can look at the EPIC's website by manufacturer to try to find it. You can search on Tech Talk. So the motor record doesn't do itself coordinations of several different motors. It certainly is possible to have a soft motor that's talking to a database that ends up controlling the values of several motors. For example, you might have a soft motor energy that controls a double crystal monochromator and actually moves 3 motors to achieve a certain beamline energy. But the motor record doesn't have that stuff inside of it. It's only one axis, and it's basically for point-to-point uncoordinated moves. But it also can do, if there is support in the driver for it, you can also do trajectories. I think there are like 3 or 4 motors that have trajectory support: the Galil, and the Eurotech Ensemble, and the Newport XPS, and maybe Newport MM 4000, and I think those are the only ones that have trajectory support at the moment. So this is basically how user and dial and raw values are implemented, and you don't really need to know this unless you're trying to do something complicated, in which case you would refer back to this, but I'm not going to go over it in detail. Originally, the motor record was written for one particular stepper motor controller, and the model is still a little bit it still adheres a little bit to that model, which is unfortunate because it's also being now used for servos and other things. Some of the controllers, you have to write the step value into the hardware for the VME58, for example, motor controller. But some of them, you have to write the dial value directly. And then all of the rest of this stuff about user and dial, and well, dial still works, but the raw value then is useless. It doesn't do you any good, and it's not actually used. If the raw value is used, MRes is what converts raw values. That's motor resolution. There are actually 2 different ways of setting MRes, and but I always just use MRes. There's another method for the number of steps per revolution, and I don't remember exactly how it works because I never use it. I just always write to MRes, and that's the distance in a single motor step. You can do absolute and relative and incremental. I showed you the tweak buttons. There's also a field into which you can write a relative value. And that's this guy. So you can home if the motor supports that. You can jog, and then it will jog until you, as long as you hold this down until you lift it up. There are actually 2 stop buttons, and this is the source of a lot of confusion. And probably a bad implementation. This is just the stop field. You write a 1 to that thing, and the thing stops, and then it sets itself back to 0. This stop, pause, move was implemented because one of the developers of insertion devices insisted that they be able to type in a value and see that that value was good, and then separately push something that made it go. And in particular, you could say move, and then it would go back to stop afterwards. or you can just push this, and then that means that it will respond immediately to motor values. So there's a whole bunch of fields for speed, base speed, acceleration. The motor record implements backlash takeout or backlash correction in the event that motion in one direction, if there's like gear or something like, well, everybody knows what backlash is, right? And it also tries to reproduce the history of the motion, so that in every time you get to a point, you get there from at least a certain distance away and moving at a certain speed and at a certain acceleration, so that the history of the motion is the same every time. And that protects against backlash and shaft wind-up and all that. But there is one exception to that. See, normally what's happening is if this is your target position and here's where you're at, the motor will move here at its normal speed, and then it will basically stop, and then it will make another move at the backlash speed and acceleration and get to the target. And if depending on where the backlash, what the backlash direction is, if it starts over here, it will again move to this point and then make a separate move to the target at the backlash speed and acceleration. There is one exception. If the backlash speed and acceleration are the same as the normal speed and acceleration, and you're going in the backlash, the preferred direction, it will just go straight to the target, because that will still reproduce the shaft wind up and the backlash.
A question.
Yes.
So the second stop button, how is it different from the first button, from the first stop on another screen?
The first button, you just write a 1 to it and the motor
Yeah,
stops, and then it goes to 0.
And if I
This guy
press
here is, it's stop, pause, move, and this actually should say go.
Yeah, but if I, for example, have two screens open, and my motor is moving, I press stop on the first screen, it stops. What if I press the stop on the second screen?
Okay, so the question is, what happens if you have both of these stop values and you press stop in this screen? This stop stays stopped, and the motor won't move in any screen until somebody puts this thing into go.
Oh, well.
Right? Mm-hmm. So, and the way it was intended to be used was that it would be in stop at all times for a motor that you're really frightened about. It's going to get into trouble. You would push move, and it would do that one move, but then it would go back into stop. All right? So normally all of our motors are in go at all times, because we almost never really require this. If we do have this, we protect it with a state notation language program, more likely. You can also, for most controllers, specify an actual motor command here that happens immediately before the move and immediately after the move. And the only case in which that's been used, as far as I know, is for brakes. Motors that have brakes that will turn off the brake, allow the motor to move, and then push the brake back on. For servos, you can enable and disable torque.
So the pre and the post move string is a string command sent to the controller.
Yeah, the question is what this string command is. This is an actual command sent to the controller. And there should be documentation for the record type whether or not this is something you can even do. I think for many controllers this is not even implemented. Also, the motor record has the ability to do retries. If you have an encoder and you tell the motor to go to a certain position and it gets there, but it's not within the retry deadband, then you can specify the number of times you want the motor to try again to get there. You can also specify a readback input link in the event there isn't an encoder, but you have some separate EPIX PV that you want the motor record to try to control effectively. It's not like PID loop or anything like that. It's just going to try to go to that. It's just going to use that EPIX PV as its readback. And if you want to do that, you press this, use readback if present is what the name of this field is. And there might be a delay. You can specify a delay so that you know that that readback value has actually arrived at the motor. because this is from an input link. And that's just a regular input link like we've already seen in other Epix records. Any others?
Enable and disable talk.
Oh, this guy?
Yeah. What situation we need to enable, disable?
So-
Normally enable?
The question is, what is this torque enable and disable for? This is for servo motors that allow you to send a command to turn off the torque so that you can move the motor manually. And typically they come up, after a boot, they come up disabled. And you have to go to the screen and push the enable to allow that motor to move. That's true for Aerotech Ensemble at least.
So that means that the driver should support this functionality.
So the comment was that means the driver has to support this, and that's true. If the driver doesn't support this functionality, the consequence is that it just will ignore this.
And is it required for a driver to support this functionality? So there are a lot of, like, list of drivers that are available in the motor record. The question is, does every driver support this functionality, or we don't know?
So the question is, does every driver support this? And the answer is no, most drivers don't. Only servos, and I'm not sure if it's all servos, but all the servos that I've ever used do support that.
Which is Aerotech Ensemble and
I've used only Aerotech and Galil.
The PI piezo's actually support that. It
The-
has to be enabled for the PI 621.
So the comment is that the PI piezos also support that, and
Otherwise it won't move.
otherwise it
The
won't move.
piezo's expansions don't.
Yes.
And Galil control, as far as I know, they do not support encoder readings. Or maybe I'm mistaken. But the server does need a feedback. Does the Galil controller support encoders?
Yes.
Yes.
Question is, does the
Yes.
Galil support encoders? And in my experience, yes.
Yeah,
It
okay.
might be possible to get one that doesn't, because
Okay.
there's a lot of flexibility in that driver. But the one that I've only seen one, and the
Okay.
one that I've seen does support.
Okay.
Hey Tim,
Yes.
what's the difference between because some controllers have the position setting inside the controller itself, and on the motor record you have this retry deadband. What's the relationship between this retry deadband and the in position, let's say, setting within the controller?
Okay, so the question is, some controllers have this retry built into them because they're servos and they're basically doing an active PID loop. So what's the relationship between that and the Epix retry? And the answer is that the Epix retry is after the fact. After the motor says it's done moving and thinks it's in position, the motor record will in any case look at this value, and if it doesn't like it, if the value doesn't agree within the deadband, it will try again. So if you have a servo and you know that there's going to be maybe 5 or 6 encoder ticks of slop in its location, then you really need to set the retry deadband larger than that.
So this retry deadband is checked after the motion down. Let's say the motion down signal coming out from the controller, right?
That's right. The retry is unless the number of retries is 0, the motor record will, after the motor says it's done, it will look at that and make sure that it's satisfied that you're close enough to the target position.
Thank you.
But does that also need the use encoder? Yes.
So the question is, does it also need the use encoder? Yes. If there is an encoder, you do have to say yes.
So
If there's an
for if you don't say use encoder, you say use encoder no, then do we still do the retry?
That's a good question, and I don't know the answer. The question is, if you say use encoder no and use readback no, does it still do retries? Because in that event, it's always just about the number of steps you've gone.
Right.
I don't think it can do retries in that case, but I'm not sure. So. Oh, one other thing. This set use and the offset, if you use set well, if the offset is variable, then it's possible for user and dial values to differ. You can fix the relationship between those two at 0 or at any number you choose, and then set this to fixed, and then there will be a fixed relationship between user and dial that can't be changed with the set switch. That's helpful mostly for soft motors. There's a maximum velocity, and there's a normal velocity or slew velocity, and there's a base velocity. For stepper motors, you guys probably know that stepper motors, if you go too slow, they will just chatter. There's a resonance, and you have to start moving at a motor speed, steps per second, that is above that resonance, and that's the reason for the base speed. If you have a servo, you would set the base speed to 0. And some drivers will ignore the base speed if you don't set it to 0, if it's a servo, because it doesn't make any sense for a servo. It also doesn't make any sense for a microstepped motor because they don't have that resonance. Well, to the extent that they don't have that resonance. The higher the microstepping ratio, the less pronounced is that resonance. But for full steppers, that resonance is a serious problem. You can set a max velocity, and if you don't, the current velocity is regarded as the max velocity. And then you can set the base speed and the base acceleration and also the backlash speed and acceleration and the backlash distance. You can, if you want, set a move fraction. There's some, especially if you have an encoder and if the relationship between the position is not perfectly linear, you can set this move fraction to something less than 1, and then the motor will try to go, like, say, 90% of the way there, and then it will reassess, see how far it is away, and then it will try to go further. That only matters for stepper motors. For servos, you just let the controller do it. There are obviously safety issues with anything that is powerful enough to take off your finger, and some of the motors around here, and also at APS, some of the motors will get you into serious trouble, or more likely break equipment. So commissioning a motor is, in some cases, a pretty serious business, and you need to come at it with your eyes open. You need to pay attention because you can get into trouble with these guys. If you want to jog, you can set the jog speed and the jog acceleration. If you use these jog buttons, which move the motor while you're holding the button down and then stop when you pick it up. I don't think these are very good ideas, and I would not have put those in there because if you have a network storm and you told that thing to jog, you are not going to be able to tell it to stop jogging if you lose connection to the crate. So I never use those.
Actually, in CSS, it's more dangerous because there's no implementation of holding and releasing. So you press this thing and then you press again to stop. It's really dangerous.
Oh, the comment was in CSS, there isn't an implementation that allows you to push this button down and then release it. In CSS, you have to do it twice, and so I would say that you guys, it's very dangerous. You guys should just not use this button, and you should take this button off of your custom OPI display. That's probably, thank you. That's a good idea. So there are limit values. You can specify in both user and dial the high limit and the low limit, and the motor will just ignore any attempt to move it past that limit. It will clip the value that you write into the val field or the deval field. The val field or the deval field. It will just ignore it, like other EPIX records. It will just ignore any command to move beyond those limits. Actually, That's not true. The motor record is different from other records. It won't clip at that. It will simply ignore a value that is outside of the limits. It won't try to go all the way to the limit. You can also send the motor controller a primitive command at initialization, just like the pre-move and post-move commands. This is dependent on whoever wrote the driver for this thing, but there's an init field in addition to the pre-move and the post-move fields, and those are just string fields, epic string, 40 characters. So if you've got a long command, you're out of luck. Somebody has to re-implement that. Okay, I don't know what this means. Some of the fields are motor type specific. Stepper motors don't have PID parameters. Only servos have those. As I mentioned, the base speed is only for stepper motors. And the soft motor has a done input link so that you can combine the done moving values of several different motors into one value to send into the soft motor. I think this is the implementation of that is going to change. So in practice, to configure a motor, you set the engineering units, millimeters, degrees, whatever it is, set the motor resolution so that it will be the number of steps that is equivalent to that engineering unit. Right. I don't think I need to go into these details. So these are the two things. There's units per revolution and then steps per revolution, and then there's MRes, which is these guys are basically a different way of specifying MRes, and most people just specify MRes. It kind of makes sense if you have a motor that's driving something else to use this and separate that into two pieces, but most people just do MRes. And you shouldn't change it while the motor's moving. That could be exciting. Yeah, I think I've already said this stuff. Looks like I didn't follow the flow here. And this is in, I think, a little bit more detail than I want to go into in this talk. But you will have this talk to refer to if you do want to go into this level of detail.
Does changing a sign on the MRS would change the direction?
That's right. The comment is that changing the sign of the MRes field would change the direction of the motor, and yes, it would.
Would that also change the sign of the limits?
The question is, would that also change the sign of the limits? No, it wouldn't. The high limit has to be larger numerically than the low limit. It would change what they mean in physical terms, but it wouldn't change the math. And all the MRes, if MRes is negative, all that means is that the value coming from the encoder is going to be multiplied by -1 before it's actually used. So we've already gone over all this stuff. Well, I did this in the wrong order. Looks like that's it for the motor, unless people have comments or questions.
How to determine backlash distance?
The question is, how do you determine the backlash distance? Maybe the best way to do that is if you actually have an encoder that's telling you where the stage is. you can move the motor and then try to move backwards and see how long it takes, how far you have to move before the encoder begins to move. And that's your first cut at the backlash distance. I would then make it the actual backlash distance approximately twice that value, because it might vary. It might be different in different spots. And the final test is that when you try to move to a position, do you actually get there reliably? So part of the commissioning of a motor would involve moving to a known position and looking at the encoder and seeing whether you got where you wanted to go, then moving in from the other direction to see if you actually got where you wanted to go. And if you don't get the same value, then probably your backlash distance is too small, or your backlash speed and acceleration are too large.
So this backlash distance must be entered to the screen you showed before, right?
Yeah, the comment is that the backlash distance has to be entered into the display, and yeah, that's true. Or you can also have that entered into a database. But yeah, you have to enter that into, and that becomes part of the motor configuration that gets auto-saved and restored, and that's part of the reason why our beamlines are so dependent on autosave, because they have like 40 motors, and they all have backlash speeds and backlash accelerations and backlash distances, and if those things get messed up, then their motions are no longer reliable. So they need all of those parameters to come back every time, and they need to know that it's never going to fail.
Thank you.
But if you have an encoder, why would you need a backlash?
The question is, if you have an encoder, why would you need a backlash? Because you want the motor to move the first time to get to the right spot. But you're right, if you have an encoder, you'll know where you are.
Yeah.
And the motor will notice if it's outside of the retry deadband from the position that it wanted to get to, it will know and it will retry. So you're right. It's
Or maybe
backlash
not.
distance.
It just overshoots.
No,
You
no,
can't
it
get-
depends where the encoder is mounted. If the encoder is mounted on the back of the shaft, right, it's a rotary encoder, then you still need the backlash. If the encoder is a linear encoder which is mounted on the table, then you probably don't need that.
That's a good point. The comment was that if you have a shaft encoder on a motor, and so the actual motion is not encoded, but only the motor's motion, then you will still need backlash takeout.
Then your real feedback should be a beam, for example, or something else. Because if you don't have an encoder on the linear motion, then you have no means to understand how much you have to go back.
So the comment is, if you don't have an encoder on the actual motion, you're just in trouble. And yeah, that is technically true, but the problem is there are going to be so many motors that you really can't put encoders on every single one of them, on every single motion. Even if you don't have an encoder, backlash takeout can improve the precision of the motion, so that it's the same every time. Even if it's in error every time, at least it will be the same every time. And scientists
You
are...
have to determine the correct value if you don't have any, reliable measurement tools to find out the backlash. You know that it's overshooting, but how much? And how do you know that it's overshooting? So one way is you see the beam, or the beam is located, and then you move it. Other ways, I don't know.
Right. I mean, the comment is that, again, if you don't have good information about where the stage actually is, you're in trouble and you have a problem that you have to solve. And the motor record really is not going to be that much help. That's more of a metrology problem. And you might, in the commissioning of that motor, get an interferometer to look at it, and then that will tell you, the scientists it'll pretty much be in the hands of the scientists at that point. And they will figure out how to get what they want, get that motor to do what they want, and work around any errors in it. But you're right, for precision motion, it's hard. Precision motion is hard. I don't have anything else in this talk.
So one more question. If you have an encoder, we have a play in a gearbox, and someplace the motor starts spinning very fast. is which of the velocities to set.
I'm not sure I understand.
So,
You-
so the encoder is on the axis, not on the shaft of the motor. So motor starts spinning, but it doesn't see the motion. It doesn't see that the motor is actually moving.
So
So
you're
the-
saying that the motor is spinning, but it's not actually causing the stage to
Causing the
move.
stage to move. And sometimes it goes to pretty high velocity before it starts moving, and then it starts moving with the prescribed velocities. Is there something in motor record that we could adjust for that?
So the question is, does the motor record have any help for that? And I believe the answer is no. If there is that much backlash,
Well, I think if you use, in our case, we basically do PID loop tuning, even though it's a step mode.
Right.
So I think you have to change the P value to smaller.
Yeah. I mean, what I'm doing is I'm going inside of the controller, and there is maximal velocity also there in the controller.
But that's
But
jog speed.
no, there's another speed.
There's another speed.
Yeah, there's a 26, X26 or something like that. That you can set the maximum velocity.
The real output on ours is the IX69.
That's the voltage.
That's the, well, for the steppers, it's output from the feedback loop, the internal servo loop outputs some amount of bits from, well, I can talk to you later.
okay, so that's probably an offline conversation about
It's not motor record.
about implementing a stepper motor with the delta tau and the tuning that's involved in doing that,
But
and
that's a common problem with any stage.
that's a common problem with any stage here. Is that right?
No, but in general, because I mean, some of the, for example, encoders that I have on the stages, like for Kuber, it's 1 nanometer encoders, but there's so much gearing before that the motor is already spinning quite a bit, and then the stage starts moving. So encoder is the velocity condition of the motor record is not met. Initially, there's a jump. The actual motor record doesn't see the motion.
Okay, so the question is that the motor record is probably not ready for situations in which there is a huge amount of backlash, so that the motor just spins freely and then nothing happens for a long time. So then the actual motion ends up being faster than you asked for
Initially.
when it hits, when it finally engages.
The other thing I've done is do a longer acceleration so that you give the controller more time to.
S-curve and stuff, but it's, yeah. But it can bounce back and forth because of the
So should we take a break before starting calc?
yeah, probably makes sense.
Okay.